We're going to have a quick review of polar coordinates. Now, I'm assuming you know this already. I'm just going to remind you a few things about it because now they're going into full details. The polar grid consists of the positive x-axis. The origin, so to speak, is called the pole. And if you recall, if we rotate in a counterclockwise manner, we call that positive rotation. And a clockwise manner would be negative rotation. And points in polar grid are defined by r and theta. And the way we do this, if you recall, we try to rotate first. And if r is positive, we move towards theta, so to speak, and if it's r is negative, we move away or in the opposite direction of theta. Alright, so I need to remind you a few things as well, really quick. We need to talk about the 30, 60, 90 triangle and see how that applies. That is, if I have a triangle, if that's 30, that's automatically 60 degrees. Well, if I label the side opposite of 31, the hypotenuse is 2, and the remaining side opposite of 60 degrees would be radical 3. And another special triangle is the 45 degrees, 45 degrees. So if I label this side 1, this is automatically 1, and this is radical 2. And that's the best way to recognize what the sine and cosine of most of these angles are going to equal. The one thing that those triangles cannot tell you whether we have positive or negative. This is a quick run if you remember how this works. If we take 45 degrees, that is really pi over 4. And if we look at 30 degrees, that is pi over 6. And 60 degrees is 2 times, that makes it pi over 3. If I want to label those, if I run to the halves, I would label this as pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4 is 2 pi. If I run to the 30s and say that is pi over 6, this is 2 pi over 6 reduced, 3 pi over 6, 4 pi over 6 reduced, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6 reduced, 9 pi over 6, 10 pi over 6 reduced, 11 pi over 6, and 12 pi over 6 reduced. And if you were to remember that at this point, oh boy, this point happened to be 1, 0. This point is negative 1, 0. This is 0, 1. And this point was 0, negative 1, because this is a unit circle, which is trig is based on. And back in trig, you might have not seen those two triangles. You might have just memorized that this is radical 3 over 2, 1/2. This is radical 2 over 2, radical 2 over 2. And this is 1/2 radical 3 over 2, right? And remember that all students take calculus, which indicates all the trig functions are positive in quadrant 1. Only the sine is positive in quadrant 2. Only the tan is positive in quadrant 3. And only the cosine is positive in quadrant 4. Since if you have a unit circle, you could replace the x and the y by x would become the cosine of theta and y would become the sine of theta. I could derive all of this for you, but that will take a lot of time, and hopefully I'm reviewing the stuff that you already know. So instead of saying in quadrant 1 that positive x, positive y, and we know that tangent of theta is the cosine of theta, the sine of theta over cosine of theta, which means it's y over x. So the ratio of two positive, they're all positive. In quadrant 2, since x is negative and y is positive, instead of memorizing those, it's much easier to go by all students take calculus or all students take cocaine, whichever works, as long as you remember what is what. So we need to know those values. I suggest you make peace with those triangles. Keep in mind, you need to know where these angles are to figure out whether the value is positive or negative, which is the challenging part. That's half of the credit normally. And I forgot to mention, you could write that as 45 degrees, another 45, that's 90 degrees, 135 degrees, 180 degrees, 225 degrees, 270 degrees, 315 degrees, and 360 degrees. And if you wanted to really run this by, let's go with, if you want to go by 30, then it's a bit easier. 30, if you add another 30, that's 60 degrees, that's 90, that's 120, that's 150 degrees, 180, 210, 240, 270, 300 degrees, 330 degrees, and 360. Again, this is just for reference. You need to know where everything is. So if I start looking at this, I just need to know where it's recording. Okay, I see where it's recording. If I'm looking at this graph right here and I want to label, the book gives a few problems. A, B, F, G. I'm going to call this C. I'm going to call this D. I'm going to call this E, F, G, I, and J. If I want to label those points, this turns out to be extremely important, very important for the next section. You must get this part, this specific part more than anything. So in this case, if I look at pi over 3, there is pi over 3. Now one thing I didn't mention yet, I left it till now. Let's get things out of the way. The difference between, I said this is like the positive x-axis. The difference with it is this arrow. This arrow indicates direction. That doesn't look right. Let me write it again. This direction. That doesn't look right either. Okay, I'm going to assume it's right. So, at 0, if I don't rotate at all, at 0 degrees, I'm already pointing in the positive x direction. As I rotate, think of this as a flashlight. As I rotate, the rotation is with it. So, or the direction is with it. When I say rotate first to pi over 3, there's pi over 3, you're already pointing in that direction. If r is positive, I'm in quadrant 1. Do you notice that r is negative? That means you're going to move in the opposite direction 2 units, and here you are. And this is part A. On B, you're going to rotate instead of positive to negative 60 degrees. You are already pointing in this direction. If r is positive, you're in that quadrant. If r is negative, you go in reverse or switch the flashlight. So, I'm already pointing in this direction. Since r is positive, I move 2 units in that direction. And here I am. And that will be part B. You could do the same in the homework. You could create one of those. You're going to draw it yourself or get it from the internet. It doesn't matter. And just label all of these problems on it. If I look at F, rotate to negative 2 pi over 3. Well, in negative rotation, this is negative 2 pi over 3. Now I'm pointing in this direction. Since r is positive, I move 2 units right there. And guess what? Those two coordinates happen to be exactly the same. And if I rotate to 2 pi over 3, 2 pi over 3 is right there. And since r is negative, I'm going to move in the opposite direction, and those two turn out to be exactly the same location. Now, I picked some problems on my own since the book doesn't have enough, and we'd like a lot of practice with trig. So, if I go for C, 270 degrees, you're pointing on the negative y-axis. Since r is positive, I move in that direction 1, 2, 3, 4. And this would be my C. I go to D, rotate to pi, there's pi, I'm pointing in that direction. Since r is negative, I move in the opposite direction 1, 2, 3 units, and here I am. I get to E, rotate to negative 5 pi over 4. This is negative pi over 4, negative 2 pi over 4, negative 3, negative 4. Negative 5 pi over 4, I'm pointing in this direction. If r is positive, I'm in quadrant 2, and r is positive, so I move 2 units in that direction, and here I am. Now I would go to G, 120 degrees. Well, this is 90 and another 30. This is 120 degrees. Since r is negative, I'm going to point in the opposite direction, 1, 2, 3 units, and there's G. When I look at I, on I, I'm going to rotate 135 degrees. 135 degrees, I'm right there. Since r is negative, I'm going to point in the opposite direction, 1, 2 units, and here I am. And if I look at J, I'm going to rotate to negative 3 pi over 4. Negative 3 pi over 4 is right there. Since r is negative, I'm going to point in the opposite direction and move r away from the angle 1, 2, 3 units. Even though this is only plotting points, this turns out to be the most important aspect for you to get the graphs of polar coordinates, which is a very challenging topic. I spent a lot of time on this. I needed to get this out of the way, and that's why I'm making this section 2 lectures. 1 lecture, 2 videos each though. 1 lecture on you figuring out how to plot points before I go on and I ask you to sketch a graph of all of these other continuous polar coordinates. Or I should say polar graphs. Now, one thing about angles I need to show you. It seems if I am at a location and I add 2 pi or 360 degrees, I'm back where I started. If I add another 2 pi or 360 degrees, I'm back where I started. Those are called coterminal angles, in case you've forgotten. Coterminal angles are whatever the angle is plus or minus 2 pi k, where k would be all integers. 2 angles we need a lot would be the reference angle referring to one of these 2 triangles, or the coterminal angles. And I'll talk about the reference angle later on. So when they get to number 4 and they say, hey, oh, I forgot to give you a page with all the excitement. Page 685 in our book, we will find all of these problems. So if I take this location right here and I would like to figure out, plot the following points given polar grid, then find all the polar coordinates for each. Well, to find the polar coordinates for each, it's very easy. Just add 2 pi to each of those, and that's what it is. And I'm not graphing those because we already did. So take any angle, add 2 pi k, you're exactly where you started. And that's pretty much it for this part. Make sure you get this and give it, even though it's only a couple of problems in the homework, make sure you get that out of the way, because when we get to polar graphs, which are the heart shape, this is something that you must know.